In this video, I am going to apply Laplace transform to solve this given differential equation with initial conditions. The differential equation is fourth derivative of y minus 16y is equal to 0. And initial conditions are all zeros except y prime of 0 is equal to 1, y of 0, y double prime of 0, and y triple prime of 0 is equal to 0. So in order to solve for this differential equation using Laplace transform, we just have to apply Laplace transform to this first, okay? So Laplace transform of fourth derivative of y minus 16y is equal to Laplace transform of 0. But Laplace transform of 0 is just 0, right? So using linearity, I could break down the left side. There's going to be Laplace transform of fourth derivative of y minus 16 times Laplace transform of y, and the right hand side is 0. Now Laplace transform of fourth derivative of y is this though. Laplace transform of fourth derivative of y is going to be equal to s to the power 4 y of s minus s cube y of 0 minus s square y prime of 0 minus s y double prime of 0 minus y triple prime of 0. Now I could just plug in these values. Only y prime of 0 is 1. Everything else, these are going to be all zeros. So it's going to be s to the power 4 y of s minus s square, just s square because y prime of 0 is 1, and that's what is going to be Laplace transform of fourth derivative of y. Here I kind of clarify something in terms of notation, just so that we are on the same page. Let's say you have a function f of t. This is just some function, and you take a Laplace transform of it. This is the notation for Laplace transform. But sometimes it is also written as f of s. Little f of t is the function, and the Laplace transform of it is capital or uppercase f of s. Similarly, Laplace transform of y of t of s is going to be denoted by y of s. That's exactly what I have done here, y of s. Now let me go ahead and take this value and plug it into this equation. If I do that, this is what I am going to get. S to the power 4 times y of s minus s squared, okay, minus s squared minus 16 Laplace transform of y is going to be y of s is equal to 0. Now let's get things straight here. S to the power 4 minus 16 times y of s minus s square is equal to 0. So if I simplify it, I'm going to get y of s is equal to s square over s to the power 4 minus 16 is going to be s square plus 4 times s square minus 4. So s square minus 4, I could break it down into s plus 2 times s minus 2. All right. Now this right hand side, I could do partial fraction for it. So s square over s square plus 4 times s plus 2 times s minus 2 is going to be as plus b over s square plus 4 plus c over s plus 2 plus d over s minus 2. Now I can multiply both sides of this equation by this s square plus 4 times s plus 2 times s minus 2. If I do that, I get the following: s square on the left hand side, as plus b times s square minus 4 plus c times s square plus 4 times s minus 2 plus d times s square plus 4 times s plus 2. Now I just need to simplify all of this. Once I simplify it, actually this is what I get. Now I'm going to compare the coefficients on both sides of this equation. Coefficient of s cube is a plus c plus d on the right hand side, a plus c plus d, but there is no s cube on the left, so the coefficient must be 0. Then coefficient of s square is 1 on the left, and on the right it is b minus 2c plus 2d, and that must be equal to 1. And then coefficient of s on the right is negative 4a plus 4c plus 4d, and on the left is 0, right? And finally the constant on the left is 0 and constant on the right is negative 4b minus 8c plus 8d, all of this equal to 0. Now if you simplify all of this and solve for a, b, c and d, this is what you're gonna get. You're gonna get a is equal to 0, by the way. A is equal to 0. Then b is equal to 1/2, and c is equal to negative 1/8, and d is equal to 1/8. So now I'm going to plug in all these values actually into this equation, which has right side this. So if I do that, I get y of s is equal to as plus b. A is 0, but b is 1/2, so I'm going to put 1/2 over s square plus 4, but I'm going to write 4 as 2 square, plus c is negative 1/8, so it's going to be negative 1/8 over s plus 2, s plus 2, and then d is 1/8, is going to be 1/8 divided by s minus 2. Now I'm going to do a little bit of more simplification. Y of s is equal to 1 over 4 times 2 over s square plus a square. Okay, then negative 1 over 8 times 1 over s minus 2 plus 1 over 8 times 1 over s minus 2. At this point, I'm going to apply inverse Laplace transform to both of these sides. So that means I'm going to go ahead and apply inverse Laplace to the entire equation. So because of the linearity, I could break it down into pieces. So the left hand side is going to give me, if I apply inverse to this, inverse Laplace of y of s, okay, that's going to be equal to 1/4 times inverse Laplace of 2 over s square plus 2 square. I think this looks like an a, it should be 2 square, minus 1/8 times inverse Laplace transform of 1 over s minus minus 2. Then finally, it's going to be plus 1 over 8 times inverse Laplace transform of 1 over s minus 2. Now, if I kind of simplify everything and write it all together, so this is going to give me just y of t, right, is equal to 1/2 times inverse transform of, inverse Laplace transform of 2 over s square plus 2 square. There is actually a typo here. S square plus 2 square is going to be sine of 2t minus 1/8 times inverse transform of Laplace transform of 1 over s minus minus 2 is e to the power negative 2t, then plus 1/8 times e to the power 2t. So finally, this is going to be your solution to this differential equation. This looks like a lot of calculation and everything, but it's rather quite simple. You just take the differential equation, given differential equation, just apply Laplace transform to both sides, then just find the Laplace transform of the derivatives and everything else, and just come up with the expression for y of s, which is right here. Then do partial fraction and solve for the coefficients. That should finally give you the nicer expression for y of s, and then you go ahead and apply Laplace transform to both sides to get the solution to this differential equation. Again, apply Laplace transform, simplify it, do partial fraction, get the coefficients, apply inverse Laplace transform, and you will get the final answer. I hope that this discussion was helpful. Thank you very much.